Hi everyone, welcome to the 5G non-standalone optimization training. If you remember, in the previous session we covered around 6 sessions, which was covering those highlighted, which is related to accessibility, returnability, mobility, and some actions impacting the traffic and so on. And also we cover part of the 5G NSA or non-standalone cell design. You can find the playlist of the 5G non-standalone training in the top right here link. In today's session, we are going to continue with 5G NSA cell design, where we covered all the below highlighted points. But in today's session, we are going to cover the remaining parts, which is related to PCI planning, neighbor planning, and tag planning, and also for the downlink transmit power, what is the consideration, how to calculate, and how to do this and that, and also for PRACH planning. This session might be split into two sessions, just to make sure it's not very long for both sessions. So let's move forward. Just to before moving forward, but just to recall, this is like was our diagram. So like which is showing the impact of the cell design, what kind of impact what kind of cell design can impact our throughput and so on. So today's session actually will be focusing starting with the neighbor planning and the PCI planning. I would like to highlight that usually about the tag planning for 5G non-standalone, this doesn't require anything from your side. Like as we mentioned, like for the tag planning, usually if you look into this figure, it's just follow the existing 4G network. This is usually 5G non-standalone. In 5G standalone, you might also reuse whatever you have in 5G standalone, but it might have a different consideration. But for the meantime, for 5G non-standalone, you just follow the 4G part. So let's move forward to cover those highlighted points and start first with the PCI and neighbor planning. Okay, the first part I would like to cover first, it's related to 5G neighbors planning. Actually, there is a different categories of neighbor planning relations. If you already have some experience in the even 4G or 5G network, this should be very easy for you to understand. But here I just try to classify it into 5G non-standalone in the left figure as you can see here, and 5G standalone, just to give you a brief about what kind of neighbors relation required for both of them and what kind of events and so on. So first of all, I was just to highlight that in general, for the neighbor planning, it's more required for the handover, because usually for the cell specific neighbors definition usually are not required for the series selection, unless actually it's necessary to either blacklist a specific cell or apply a measurement power offset to a specific cell. Like applying a measurement power offset means that, for example, you can from during the series selection or the initial access of the UE, you can just make some cells more attractive to this UE or less attractive during tuning some of the reselection thresholds. But at the end, the neighbors definition is not really required for the selection in general. This is the first point. Second point, in 5G non-standalone general, we don't have the concept of series selection. Series selection in general is controlled by the 4G network. We don't have a series selection in 5G standalone. It's mainly controlled by the normal legacy of the selection 5G. So the first point again to recall it, like we don't really require the definition of the neighbors for the series selection unless it's mainly used or needed for a specific scenario. Just also to recall that in 4G we used to have a different system information broadcast, just to transfer this kind of information about the series selection, starting from SEP3 for interfrequency, and you have SEP4 and SEP5, which is used for interfrequency and interrat measurement, which can use to broadcast those neighbors if defined, and also to broadcast, especially for 4 and 5, to broadcast the interfrequency. And also, for example, if you are moving from one frequency within the 5G to another, interfrequency or even inter-rat. For example, if you're moving from to different rat, for example. So here, and one more important point, that usually in later on from reselection from 4G to 5G standalone, this is what require you to have the SEP24, which will be required to be enabled in the network in general. And just like as the 3GPP, the current release, actually it was supposed to be the release 15, but what I know from the network or from practical experience, that we don't have this kind of series selection or handover if you are speaking about 5G standalone, moving from 5G to 3G or 2G. It's just allowed from 5G towards the 4G. but we don't have from 5G to 3 and 2G. Anyway, so now let's just cover what we have about the neighbors in general. The figure on the left just summarizing all the type of neighbor definition you need to consider during planning the 5G non-standalone network. So, for example, if you look into this figure, you have here the A node B, which is the 4G part. You have another A node B, and you have the G node B and another G node B here. Assuming this user is moving from here till he reaches into this point. So the first part, for example, within the 4G network, this he's moving, so he can make from one 4G node to another. He can make either intra-frequency or inter or intra-frequency handover, and this is actually usually being defined by default, especially if you are just like building a 5G non-standalone network. So I suppose that this one's supposed to be optimized, but again, this is still very important to make sure that it's correctly defined and have no issues or problems, because again, this can cause a problem in 5G non-standalone. So here, usually the inter-frequency is using event A3, and inter-frequency is using either A4 or A5 events, as mentioned here. And here is the formula for the A3, just for your reference, and also for A5 here. Those is usually the formula which was being used by both of them. In A5, A3 just based on offset. You just give offset differences between the survey and neighbors. For example, if the neighbor is better than the offset by 3 dB, 4 dB, 5 dB, based on whatever the value will give and achieved for a specific time to trigger, then the handover will start triggering. A5 event is the most common use now, more than the A4. A5 event just having a two condition, usually called threshold 1, threshold 2, where the measurement here, as you can see, plus the hysteresis for the serving cell supposed to be less than threshold 1. So this is the first condition. And another condition must be achieved in order to the user to move to the neighbor cell. So first, there is a condition: the serving should be worse than a particular threshold where you define it in your configuration. Then the neighbors should be great. The neighbor or the target or the candidate neighbors should be better than a threshold 2, which is also configured value in the network, and also hysteresis and others are being configured. So this is the A5 event. Now, the most important, once you latch to this inode B, which is having a co-located, for example, site, Unit B5, 5G non-standalone site, and now the UE required now, and the UE is capable of 5G, and use suppose that he's here now, or he's here. So he's supposed now to start measuring the related frequency and related information about the 5G network in order to start latch or attach to 5G network. How this can be done? Inode B will deliver something called event P1 and time to trigger and so on. And based on this, once the UE received event P1, he'll start measuring the frequency which is being sent from the inode B to the UE in RSA configuration message. Start measuring until he found the specific neighbor, so he report the B1 event. For example, if the B1 event as shown in these formulas here, one for B1 event, if the UE reported, for example, that the RSRP of the unit B is achieving the event P1 threshold for this particular time to trigger, so then he will report the measurement report. Then they will start in this process which we discussed in details in the previous session. You can even refer to the accessibility part. This will be covering that SUGN addition will be added. Once the user attached to unit B, assuming that he moved within the same site from one cell to another or from another site, this will trigger something called BSL change, like primary secondary cell change. For example, it's changing the secondary cell of the unit B to another one. So this is usually used if intra-frequency handover, it will be using A3. If inter-frequency handover, it will be used A5. And the good point here that A3 and A5 is exactly the same as whatever you used to have in the 4G as a concept or conceptual point of view. And just an ad hoc or additional point here, usually the ANR can be used to populate a set of neighbors relation. Usually the ANR can be used in a non-standalone network, but it's depend, because actually the main idea that enabling the ANR automatic neighbor relation, which is some feature in 5G non-standalone, this is actually requires activating something called SIB1, which is System Information Broadcast 1, because at the end the user need to read the CGI and report the CGI to the E node B or to the G node B until he like to be able to help the E node B or the G node B to add the required neighbors definition. And in general, SIB1 is mandatory or must in 5G standalone, but it's not required in non-standalone. So again, if SIB1 is not enabled, this is even if you enable the NR, probably it will not be work unless your vendor, for example, have another specific solution. For example, some can be used only if assuming the X2 relation is being defined. So can be added, but in general, as a concept, if NR is not is used without SIB1, enabling SIB1 in 5G net standalone, this means it will not be working. And also, I have a video explaining this part. You can refer to this video in my channel. Just here to quickly recap, the 5G standalone neighbors, or just to quickly summarize, in other words, 5G standalone neighbors actually it's very simple compared to non-standalone. Like as you can see here, we have just the E node B to G node B. This is required IRAT, even release with direction or handover, and this is based on event B1 and sometimes can be B2 as well. And from G node B to G node B just require the normal intra-frequency or inter-frequency handover, which is used event A3 and A5. It's more simplified because we don't have this section where we need to have this kind of additional between 4G and 4G and so on. So it's mainly like the normal legacy. For example, if you mention as 4G, it will be something like 4G if you replace E node B with 3G and G node B with 5G. So in general, you have here reselection or handover, reuse direction or handover from 4G to 5G. Then you have inter frequency. This is a majority of what we need to cover about the neighbors definition. So now let's me jump to the next section. Here for this section, it's about the 5G PCI planning. I just try to summarize the main consideration which we usually consider or main requirement whenever we start the PCI plan. But let me stress on one point. To be honest about especially the PCI planning, and neighbors is also required to be giving a very special focus, but especially for PCI planning, we have a tools to do that. We have a tools, but we need still to understand whatever you have, because even the tools is doing the planning and so on, still you will find many problems in the network. So you need to understand the basic background about what kind of problems you might face to be able even to troubleshoot or improve the network. So just 5G in general introduced extra PCIs compared to the 4G. It's almost double, as you can see. It's double. Before in 4G we used to have 504 PCI. Now in NR we have 1008 PCI. As you can see, it was both of them is group of 3, but now we have 336 compared to the 4G. And in 3G before, we used to use this kind of scrambling code. So the main consideration, the most important for the consideration, more than anything else, it's about the PCI conflict, which is categorized into collision or confusion free. Like I will explain this part in details, but just as mentioned here in summary, the collision means that you have two sites neighbor to each other and they're using the same PCI. Very easy one, like both of them having the same PCI. We'll explain this one in more details next slide. And confusion, for example, you have one serving cell with two neighbors, both neighbors using the same PCI. So the serving would be confused. This PCI is related to which neighbor. So this might lead into problems in general and handover. And we have this PCI mod 3 and 4 and 30 planning concepts in the 5G. Before in 4G, it was mainly about 3 and 30, where we have this 3 being mainly used in synchronization signals, which is in the second SSS and BSS and so on. Usually that's BSSS, primary synchronization signals. And we have PCI mode 4 is used for downlink reference signal, usually for the DMRS for the broadcast channel. I will go through all of that. And we have mode 30, which is exactly the same as whatever you used to have in 4G, which is about the uplink DMRS reference signal. And one important point that you just need to understand or keep it in your mind. Whenever you go to any network, you'll find most of the time, they are reserving some of the PCIs. For example, they will not consider the complete 1008 PCIs during the planning or during designing the PCI. They will reserve, for example, 200 or 300 PCI, let's say from 700 to 1008 for the future use. In case if they have additional expansions, you need to make some femto cells, micro cells, whatever. So this can be considered for future use. to be only used by those particular cells. So usually you will see that not all PCIs are being used, and this is something like common between most of the operators. And again, so the main consideration also, you need to make sure that plan to maximize the reuse distance as much as you can to just avoid having the same PCI for the nearby sites. And yeah, and this is required in order to never to allow the user never to be able to receive the same PCI from different, for example, frequencies and so on. So now let's move forward about the more concept about the PCI. The first part here, I'm going to cover about the PCI planning for mode 3 and mode 4 and 30 planning. Just quickly to recap, this is again, it's very similar to the 4G, but the main difference is that in 4G, everything was being done based on the cell-specific reference signal, where even your quality or CQI, it was being estimated by that. So that the interference or mode 3 was kind of more crucial, more critical to compare to 5G, because everything was based on the evaluation based on this cell specific reference signal. Okay, so this means that in 4G it was very important to have this kind of very like as much as you can to reduce this kind of interference. In 4G, this is like, for example, Mod 3, as you can see here, it's mainly based on the synchronization signals, which is synchronization signal particularly for about the PSSS. Okay, as you know, that PSS has three groups. So this PSS indicates the PCI within group 1 to 3. So this is means that you have three, right? So this means now it creates the rule that to have like this kind of mode 3 interference. So for example, each cell will have a different mode. For example, PCI 1, 2, 3. So each one will have a different mode. So to avoid within the site, or even try to do it with the neighbor cells, to avoid this kind of mode 3 interference. And as mentioned here, for example, this is based on some simulations, and this is quoted from 5G NR bullets, based on some simulation that if you have this kind of mode 3 interference, so this is, can make the cell acquisition, like during the initial access, to the time itself to increase. So if in case if the user receive the same PSS with the same mode from different multiple cells. So this is about the first thing about mode 3. For the DMRS, broadcast DMRS, as you know that we also covered the DMRS part in the detailed section. You can refer to the channel for this video. But as you know that in general, the distribution of the DMRS within the broadcast channel, which is here, this one, which is like every fourth, as you can see, sub carrier. So you can, for example, here the first one, you have the second, third, fourth, and so on. So you can see, for example, PCI 0 require to have the first here, the first one, and then the broadcast will have a DMRS. Then it will again coming here. PCI 1 should be the planning coming here, and PCI 3 should come here, and so on. So in general, the DMRS of broadcast used to estimate the channel propagation by the broadcast, and this is actually information is also very important. And usually, this is as you mentioned, the DMRS is allocated usually every fourth resource element. So it's good to have it in this kind of design, since it's allocated every fourth. So it's using PCI mode 4. So as you can see here, for example, if it's PCI 0 here, PCI 1 here, and so on. And just quick point to highlight that in case if you have a BTS being allocated with a PCI group, as you can see here with three, like for example, and three consecutive PCIs and shown here. So this will directly lead that both PCI mode 3 and 4 will be satisfied within the same BTS. So in safe in case if you have this kind of consecutive PCI allocation, so this will achieve both modes together. And again, this will be done by the tools. Okay, so just here the last one, that's about the uplink reference signal. Just to quickly recap something here, I would like to show how the figure looks like in the frame. Again, here you have the SSP, as we mentioned, that for the SSS required BSSS surely required mode 3 planning, and the broadcast required mode 4 planning. And now we're speaking about the DMRS, which is located here, as you can see in this location, and this is required actually a mode 30. So just again, the uplink referencing require a mode 30 planning, and usually the mode 30 planning if 3 is being already designed, so this one also will be achieved. So we don't really like worry much about it, because it will be already covered within the initial planning for and using the tools and so on. So let's move forward now for the next. Okay, the last part here, it's one of the very basics, I think. We need to quickly cover about it. It's about the type of the PCI conflict, which is having two types, PCI collision and confusion. As you can see, the figure in the top right here, this is covering the PCI collision, where you have cell 1 and cell 2. Both are operating within the same frequency, for sure, same frequency. And for example, both of them are using PCI 1, PCI 1. So this is the user will have a conflict. He will not understand in the measurement, you will not understand anything about that because two cells having a conflict. So in this case, this will lead into a mutual signal interference overlapping, and the UE will fail to decode or correctly decode the signal because of this conflict. So this will increase actually the service drop rate, and even the handover will be impacted and so on. And this is usually if you have, that's why they have this concept of free use distance. You need to have a higher use distance for the BCIs. And the second concept is about the PCI confusion. As you can see, this is a serving cell 1, and you have cell 2 here. This is a typo, and you have cell 3 here. So the neighbor cells, which cell 2 and cell 3, is being used the same frequency with the same BCI, which is BCI 1. So once a user moves, for example, and starts reporting the BCI to the serving unit B, the unit B cannot, in this case, cannot determine that the neighboring cell is for which frequency that you has measured based on the reported BCIs. So therefore, it cannot understand because both are being configured within the cell. So it will not understand this is related to which cell, either cell 2 or cell 3. So this will make a confusion. So in this case, the performance cannot be done. The handover cannot be done in this case. In some cases, this can be mitigated if you have the SOM feature being enabled in the network. Like in this SOM feature, in this case, the the unit B will instruct the UE to start reading the CGI for those two cells and report it back to be able to make the handover. So in case if the NR is being enabled and the user supporting the CGI, so in this case the handover can work easily with for sure some impact, but the best case to try to avoid this scenario where you have the serving or any site in the network configured with two nearby neighbors with the same BCI to avoid this kind of BCI confusion scenario. And this will what we are going to cover today. Let me just next slide quickly. Okay, this is what we're going to cover next about the 5G downlink transmit power. We'll try to cover very important concepts and also the calculation and try to cover to make you understand really how the power can be calculated, what it means by EIRP, what is effective isotropic radiated power, what is mean by EPRE, energy per resource element, and many other stuff. This is to make it very clear for you about all the concept about the power, what is the relation between how to calculate something called cell reference power, what is the relation with other channels, for example, the CSIRS, BDCH, SSP, and so on. This kind of all things will be covered in the separate section because it might take some time. So, and this is also some of the whatever we're going to cover in next slide, the next session. So just stay tuned for the next session about the downlink transmit power of cell power design. And if you like the video, to share it and to click like and to spread the knowledge. Thank you very much and see you next video.